Okay, we'll get back to the notes here. We're on problem 29. We're solving quadratic equations, and so all these problems here that we're looking at so far are applications of quadratic equations, right? So we got to read the information, then set up the equation that represents what's going on, and then solve the equation. Okay. In problem 29, it says that a rectangular piece of metal is 10 inches longer than it is wide. Squares with sides 2 inches long are cut from the four corners, and then the edges are folded upward to form an open box. If the volume of the box is 832 cubic inches, what were the original dimensions of the piece of metal? Okay, so we have this piece of metal, which is the shape of a rectangle. Okay, and we don't know the length of the width, right? That's what we're supposed to find here. So the length, I'll call that L, and the width, we'll call that W. Now, we don't know the length, but we do know that the length is 10 inches longer than it is wide. Okay, so whatever the width is, you're going to add 10 to the width to get the length. And that'd be W plus 10. Okay, we're cutting out squares from each of the four corners there, and each side of the square is 2 inches. Okay, and then once we remove these four corners, we're going to fold up the remains to form a box. The box will be open up at the top. Okay, the volume of the box is 832 cubic inches. Now, by them giving me that information, that suggests that I need to be working with the general formula for the volume of any box. The volume of any box is where I take length times width times height. Okay, so the volume of this box is 832. And that's equal to length times the width times the height. Now, when I remove these four corners and I fold this piece of metal up, it's going to be 2 inches tall, right? So the height would be 2 inches. And then the length, okay, so W plus 10, that's the length of the metal. That's not what I'm asking for. I need to know the length of the box. Okay, so W plus 10 is the length of the metal, but we're subtracting 2 inches on the right and 2 inches on the left. So ultimately, we're subtracting 4 inches from W plus 10. That's going to give us W plus 6. Okay. And then the width of the box is what? Well, W is the width of the metal. Again, that's not what I'm asking for. I need to know the width of the box. Okay, so I'm subtracting 2 inches up top, 2 inches down under. Right, so ultimately I'm subtracting 4 inches from W, or the width of the box then would be W minus 4. Okay, so this equation here, that'd be the setup that we'd need to solve. And let's see, if I solve this, if I factor out W plus 6 times W minus 4, that's me W squared plus 2W minus 24. Okay, and then multiply that by 2. So you're going to have 2W squared plus 4W minus 2 times 24 would be 48. Okay, let me get everything onto one side here. So let's subtract 832 from both sides. You have 2W squared plus 4W, and then negative 48 minus 832, that'd be minus 880. That's all equal to 0. Okay, and I can make the numbers a bit nicer here. All three of these numbers are even numbers. Right, so 2 goes into all three of those numbers. And if we divide both sides by 2, we're going to have W squared plus 2W plus, or minus 440. That's all equal to 0. Okay, so then the next thing is, here's my quadratic equation. If we try to factor this, this should factor. Okay, it's going to be W and W, and then 22 and 20. 22 times 20 is 440, and then 22 minus 20 is 2. Okay, again, not everyone's going to see the factorization there. So if you don't see the factorization, use the quadratic formula. Okay. So anyway, this did factor. W plus 22 equals 0 means that W is negative 22. W minus 20 equals 0 means that W is 20. Now W is the width of the metal. That can't be a negative. That doesn't make sense. All right, so throw away the negative 22 there. And it looks like the width of the metal is going to be 20 inches. And then the length of the metal would be 10 inches more than that, so that'd be 30 inches. Okay, so the dimensions of the piece of metal are 20 inches by 30 inches. Problem 30, so we're going to be graphing quadratic functions. Now there's two common methods to graph a quadratic function. By the way, when you graph a quadratic function, you're graphing a parabola. Okay, so that's the kind of curve that I'm going to be drawing here. The two common methods, so one of them is just to use a list of steps to draw the parabola, and then the other method is to use what we know about transformations. Okay, so in problem 30, we want to graph the quadratic function f of x equal negative 3x squared plus 12x minus 11 by determining the vertex, the intercepts, and whether the graph opens up or down. That's method 1. Okay, so the first thing is to determine if the parabola is opening up or down. We're going to know that immediately. So A is, it should be A equals negative 3 there. A equals negative 3. Negative 3 is less than 0, right? So that means that the parabola opens down. Okay, if A is a positive, the parabola is going to open up, right? So this parabola is going to open down, with A being a negative 3 there. The vertex is equal to the point negative b over 2a, and then f of negative b over 2a. So a is negative 3, we already said that, right? And b is 12. So the opposite of b, that'd be negative 12, divided by 2a. 2 times negative 3 is negative 6. Negative 12 over negative 6 is 2. Okay, and then I need to find f of 2 to get the y value. So if I plug 2 into the function, 2 squared is 4 times negative 3, that'd be negative 12, plus 24 is 12, minus 11 is 1. Okay, so this point 2, 1, that'd be the vertex of the parabola. Now the vertex is always the highest or lowest point on the parabola, depending on if the parabola is opening up or down. So this one is going to open down, we said. So we just found the highest point on the parabola. That's at 2, 1. Step 3 then is to get the intercepts. So the x-intercepts and the y-intercepts. To get the x-intercepts, I need to let y be 0. Y and f of x are the same thing. So when I say let y be 0, I actually mean let the function be 0 and solve for x. So we have the equation negative 3x squared plus 12x minus 11 equals 0. And if I multiply both sides by negative 1, then the leading term is a positive. So I'm going to have 3x squared minus 12x plus 11 equals 0. That's not going to factor nicely for me, no matter what I try for the factors. And so use the quadratic formula to solve. Okay, so we got the opposite of b, that'd be 12, plus or minus the square root of b squared negative 12 squared is 144, minus 4 times a is 3, times c c is 11, all over 2a. 2 times 3 is 6 in the denominator. Okay, so then from that we got 12 plus or minus the square root of, let's see, 12 times 11 would be 132, if you're to check that. So I got 144 minus 132, that's 12. So 12 plus or minus root 12 all over 6. Root 12 breaks down as 2 root 3. I don't think that much matters though. You see, because I'm going to have to plot these points on a graph. So I'd say when we go to the calculator next and go ahead and enter in 12 plus or minus root 12 over 6. So if I did 12 plus root 12 divided by 6, I'm getting 2.58. That's right there. And then take 12 minus root 12 divided by 6, and we get 1.42. Okay. So these would be the two x-intercepts, or where I cross the x-axis. And the y-intercepts are found when x is 0. So if x is 0, I plug that in the function there, I get negative 11 in return. Okay, so the three intercepts would be these 3 points. You got 2.580, 1.420, and then 0, negative 11. All right, so then the next thing I'm going to do is I'm going to go ahead and graph this curve here. All right, so we're drawing a parabola. This parabola opens down. The vertex is at the point 2, 1. So I'll go ahead and plot that point, 2, 1. And we found we had 3 intercepts. They're at 2.580, that's right there. 1.420, that's right there. And then 0, negative 11, that's off the scale that we've got, but that would be down here. Okay, so notice how that all 3 of those intercepts are below the vertex. That makes total sense to us, right? Because we just said that the vertex is the highest point on the graph. Okay, so then once we have those points plotted, we can then draw the parabola as best as we can there. Okay, now the parabola is going to be symmetric about the vertex. Okay, so you try to make it look like it's the same on either side of the vertex there. Okay, the reason why I'm saying it like that is like sometimes I see students will draw a curve, and they'll have this one side kind of flaring way out like this. Don't do that. Okay, that's not a parabola, and it's not symmetric. Okay, so we need something that's symmetric about 2, 1. Okay. All right, why don't we go ahead and we'll stop the video right there, and I'll pick up with problem 31 in the next video. Also, I'll probably plan to finish up this handout there in the next section. So we got up to problem 34. We'll do problems 31 through 34 in the next video.